Hello and welcome to our first tutorial on MySQL. Today we're going to go over tables, what they are, how they are stored, and how does MySQL access the data that is stored in them. I've got in my shell here a connection to my database that is powering my application. It has a number of tables, and we can see these tables by asking MySQL to kindly show us. If we show tables, we can see we've got 3 here. Now, these are all in our default DB tables in default DB. Default DB is the name of our default database. But what's interesting is that if you have an instance of a MySQL server, you can have multiple databases. You can have basically as many as you want to. But the main database we have here is called default DB, and the tables that are in it are shown here. Grizzle migrations, this is an internal migrations table. We don't have to worry about that. The ones we'll be interested in are 90-minute tracker and users. Let's look at some of the data that exists in 90-minute tracker. To do that, we can do a select star from 90-minute tracker, and we'll get a list of the rows. Now, as you can see, my application is incredibly popular. There are 4 rows in the database that is powering this tool, 90-minute tracker. And it has the general shape of the data here in the table. It looks like we have an ID column, a user ID column, date, time, past actions, etc. This is showing us the data that is stored on disk in the table and showing us everything. That's why we asked for star everything. But it doesn't show us how this data is actually defined. To look at how a table defines its data, you need to look at the table definition or schema of the data. You can do that by saying show create table 90-minute tracker. And this is going to give you the, let me move myself. This is going to give you the table definition for this table here. So you can see that most of the columns look identical. You know, we have our ID, user ID, date, time, etc. And afterwards are different qualifiers on how this data is expected to be stored and inserted. I'll go through them briefly. This is definitely more than we can cover in this video, and there'll be separate lectures on this. But I'll go through the basics, and you can kind of feel it out for yourself and see how self-explanatory it can be. Big integer just means it's an integer and it can be really, really big. Unsigned, this means no negatives. It's always a positive number, and this makes sense when we're incrementing an ID integer because a negative ID is not a common thing you'd see in a table. Not null means that there are no records that are allowed to have this column as the value null. It's not allowed. Auto increment means that MySQL keeps track of this column for us. We don't have to insert a record value into it. It will be tracked and updated by itself. The user ID, same thing, except not auto increment. Date is a date. Time is a small int, unsigned, not null. The main things you have to worry about are, do you allow nullable values? That can be specified with not null. What kind of a column is it? If it's text, you can store any amounts of string. If it's a small integer, you can store a number that's still pretty big. If it's a date, you can store a date. All of those are relatively simple and are not going to be further discussed in this video. But what this create table shows you is how your data is defined in this table. So for us, that's broken up by these different columns. And then once you get to the last column, in our case productivity, you'll see that there are different keys or constraints listed at the bottom. Now we won't dive into keys, but just know that the primary key is the thing that MySQL uses to build and find your data. A unique key is some sort of constraint we've placed on a column saying that no 2 values in any of the rows can be the same. Something like that would be our ID here. There's no 2 records with the same ID 2 because it's our unique key. A foreign key is referencing another table. So for us, we're using our user ID column as a foreign key to reference our user's table, and we're using the ID column of the user's table. This is how a table is defined, and that data is defined and stored as an integer, as unsigned, can it be null, etc. Now, how does this actually look on disk? And how does MySQL use primary keys to find data? Well, let's turn to this wonderful article that I found online. Shout out to this guy. I will leave a link in the description. But he gave us a brief discussion on the difference between a B+tree and a B-tree. You don't need to know the difference between those, and you don't even really need to know what those are, because I'm about to tell you. B plus and a B minus tree are a data structure that looks like this. And it just so happens, depending on the engine that your MySQL instance is running, you will either have B plus trees or B minus trees representing your table's data. So this is how a table's data is actually stored on the computer. There is, at the top here, what we call a root node. And the root node in a B plus tree, bear in mind, is simply a reference to an ID value. So you recall how we have IDs, ours go up to 5. Let's assume that this app gets really popular and we manage to have a 6th row in our table. This would be that ID 6, and it's just holding that ID 6. This is our root node. The node 5 over on the left is an internal node. Once again, it is just containing the value 5, representing the ID column on one of our rows. Once you get to the bottom of the B plus tree or B minus tree, you have what are called leaf nodes. And leaf nodes contain the reference to the ID and the data associated with that column. This is where all of your data is stored. So, the way MySQL goes to find a piece of data or a record goes like this. Let's say I want to run a query. I want to select star from 90-minute tracker where ID equals 4. I want this record right here, the reading Bible and praying and running breakfast person doing this. I run this, I get back my record. Great, how did that happen? Well, let's try it again, but let's run it with an explain. MySQL lets us force it to explain itself. When we run this, we see, oh, we got a different kind of table. It's not showing us the record. Instead, it's showing us ID1, a simple select type on the table 90-minute tracker. I don't know what all it means, but I'll tell you what a little bit of it means. Obviously, the table is the table that we selected, and possible keys are the keys that MySQL considered to find the record here. We're not going to dive into the different keys. That'll be a separate video. But I want to focus on the key column, which is the actual key that MySQL used. It used the primary key. Now, the primary key is referencing the primary table. The primary table is the source of truth for your data. And the primary table looks like this. So MySQL says, I'm looking for ID 4. I'm going to start at the root node. Is 4 less than or greater than 6? Well, it's less than. I'm going to go left. Okay, I went down to node number 5. It's an internal node. It just has the value 5. And I'll ask 5, am I less than you or more than you? And of course, I'm less than, so I'll go down more to the left. And now I've reached the node number 1. And I realized that this is a leaf node. So when I reach the leaf nodes, I'll just plot it along incrementally until I find the one that has the number 4. And I'll say, here's the data I want. Come back and give them this beautiful row and do it in 0.14 seconds. It's very, very fast, very optimized. So this is how MySQL stores your data in the primary key table. I'll go into further discussion on more indexes and how that actually creates more instances of this structure. You'll have multiple B trees, but the source of truth for your table is a B tree indexed by your primary key, which is why it's important, and some would say a convention, to make your primary key an integer, because it's very easy to compare integers. 6, 5, very fast, very simple. This is your data structure, and this is how MySQL is accessing your data. We will look further next video into how we can optimize this. But until then, see ya.